Today is the 2nd of May 2024. I would like to introduce standard form. That will be our introduction, that will be our first video, or standard index form. Thank you to all my subscribers. Thank you very much. If you haven't subscribed, please, if you can consider subscribing, I appreciate it. Okay. Subscribe when you get your notification, and you will share, like, follow us. As long as it's not going to charge you, it's not going to cost you, please do subscribe, okay? And follow us maybe on Twitter and other places. I'll appreciate that. And please, if the account is not yours, ask permission from the account holder. It's very, very, very important, okay? Don't use people's account anyhow, okay? Please. In the comment section, you will see, please follow my notes/script. Okay, so here again, this is a diagram. Okay, so follow the notes. Okay, don't just listen and just listen, watch it and not pay attention. If you want to watch it, sit down, watch it, follow the notes. Okay, please, I appreciate that. Please beware of scammers. Okay, beware of them, please. I'll recap. Watch last video for recap. We have done sets, SURDS, and last video was our 8th video, and I think at this level I've told you what I need to tell you about sets. I've just been doing questions and mental, using them for mental maths, to help those who are going to write exams. Okay, so the last 2 videos I did 2 mental maths with you. Okay, and I took time to explain to you. So if you've not watched it, please go and watch it. And then I think the last video we did the area of a square and rectangle, and then we left our answer in a set form. Please watch it. Go back and watch. What I'll do is, if I get any more questions like I've done in circle theorem, I'll bring it little by little. I'll use the starter to do a little bit at a time. So over a period of time, you become familiar or warm toward the topic, especially if it's one of the topics you don't like. So that will not be the end, but I'll bring it in the starter, and maybe some possible exam questions if I get some of the questions, because these questions in sets do appear in the foundation paper, both papers, foundation and higher paper. So I might just use the starter to help you revise some more, or maybe if I am able to create some of the questions, I'll just bring it to the starter and just explain it to you and tell you how to solve it. Okay, now today again we have circle theorem. You remember I told you you don't have to keep your answer paper this way. You can turn it that way. Okay, you can turn it that way. Okay, like if you're doing a DIY, you can turn it till the diagram makes sense to you. It is your exams. Okay, so you can turn it. Some people maybe might be able to see better that way. Okay, some people might be able to see it better that way. But here again, it's a cyclic quadrilateral. Okay, DEF G or GDEF. Okay, these four shapes, okay, is not to scale. Okay, and we are told that side and that side have equal length. So straight away, if that is 50, then that will be 50. Okay, if this is 50 and that is 50, the total in a triangle is 180, the total angles. So that will be 80. Again, I brought these figures for it to make it easier for you so that maybe it will be non-calculator then. So now, um, QDP is the tangent. That is the center. DEF is isosceles. Okay, this is not, again, not to scale. So in the diagram, in the question, this and that is equal. That's why if this is 50, that will be 50. Okay, it's supposed to be equal length. So maybe it should have been somewhere here. Okay, so that it can be equal length, but it's not to scale. Okay, and it's not drawn accurately. But let's follow the question, please. Now find x. X is this one here. Okay, they were asking us to find x. Now, if we use circle theorem, this angle here, okay, we are finding x. This angle here plus this angle here should add up to 180 from one of the circle theory. So if this is 80, that will be 100. So the first question is 100. Okay. Now we are supposed to find y here. Okay, this y here. Here. Okay. Now again, if that is 80, okay, if that is 80, and if that is 50, then that's 50. Okay, and that will be 80 to make it 180. Okay, so the angle at B, okay, this angle here will be equal to 50, this angle here. Okay, because B is y, this one. Okay, the angle there is 50 because 100, which is the inner one here, and that one is the outer. So if this is 100, that will be 100. So if this is 50, that will also be 50. This angle here will be 50 to make up 100. You remember the interior and the exterior on the tangent. Okay. So that will be 100. So the angle there will be 100. Okay. What circle theorem is used in this part here? Okay. Now, these questions they don't normally ask. Okay. But I had to go back and check in the introduction and in my notes. And it says alternate segment theorem. So I've written it down. You can Google it and research it. So what it says is the interior angle and the angle at the tangent, which is the exterior angle, should be the same. So if this is 100 and that is 50, then that part here, okay, is 50. Okay. So that's what I have for you. Today, we are going to look at our introduction on standard form Okay, what is standard form? I've done this with you in the earlier on. Okay, where you have a number a times 10 to the power n, and n is any number, any integers, zero included, and you can have so it's in the form a to the power n. Okay, a can be equal to 1 or more or less. Okay, so a can be less or equal to 1 or less or equal to, or less than 10. Okay, so let's look at it. So n is an integer and it can either be negative or positive. So you can have a should be like 1.0 or 1.25. Okay, and you can have 10 to the power 0, 10 to the power 5, 10 to the power minus 3. Okay, now here remember that 10 to the power 0 is 1. So let's look at examples. Okay, so assuming you have 1.25 times 10 to the power 5, the power here is positive. Okay, now a here, okay, is like 1.25 because you can't have a standard index from like 12. It should be a whole number point something. So you can have 1.0 if the number is a decimal. You can have 1.4 times 10 to the power 3. Okay, if it's 1.4, you can write it as 1.4 times 10 to the power 0 because any number to the power 0 is 1. 10 to the power 0 is 1. Okay, so I've brought you some examples. 2.1 times 10 to the power 2, 3.5 times 10 to the power 3, 4.72 times 10 to the power 0. So assuming I'm given 4.72 and I'm asked to write it in the standard form or the standard index form. Now, I can't write 0.4 because it should be 4 point something. So I can write it as 4.721 times 10 to the power 0. So that when I multiply by 10 to the power 0, which is 1, I get back the same figure. Okay, 1.1 times 10 to the power 3. Okay, so these are some of the examples. So if they ask you to leave your answer in index form, these are what you are going to write. Okay, 1.265 times 10 to the power minus 2, 4.2 times 10 to the power 0, 6.25 times 10 to the power 0, 5.234 times 10 to the power minus 3, 7.821 times 10 to the power 7. I think this is 2 or 7 or 1. Maybe it's 1. Okay, I think it's 1 here. Now we are going to look at a sample. Change standard form. Okay, by change standard form from numbers to ordinary number. So that will be the first one. But today we are going to look at just the positives. Okay, so the examples I gave you earlier We'll work with them. So the first one, 1.25 times 10 to the power 5. Okay, how do you change this? Okay, to become uh, a number. Okay, because it's already given to you in the standard form. Okay, today we will look at the standard form and change, and we are going to concentrate on the positive. Okay, multiply by 10 will make a larger number. So if you have 1 times 10, it becomes 10. Okay, so if it is 10 to the power 5, 5 is positive. So you are going to multiply by 10 to the power 5. So you are going to get a larger number than 1.25. Okay, now multiplying by 10 to the power 5 means you have to shift the decimal place 5 times towards your right hand. If you're a right-handed person, towards your right hand. If you're multiplying by a negative power, then you do it towards your left hand. Okay, that is the easiest way I think I can explain to you. So 10 to the power 25, 1.25 times 10 to the power 5. So we are going to shift it 5 places towards your right hand. So I'm going to rewrite 1.25 here. Okay, so I'm going to shift the decimal. The decimal is between 1 and 2. The decimal is always between the first two numbers. Okay, so 1, 2, 3, 4, 5. So I have 2, 5, and then the empty spaces I write 0, 0, 0. So 1.25 times 10 to the power 5. Okay, to change it to an ordinary number becomes 125 0, 0, 0, because I've got 3 zeros here. I've just brought the comma, so I have 125,000. Okay, now let's look at the negative one with the examples we saw earlier. So this is in the standard form. I want to change it into a whole number. So I have 2.1 times 10 to the power 2. So again, I'm going to shift the decimal 2 places. So 1, 2. Okay, so we move the decimal 2 places towards your right hand. This one. Okay, most people are right-handed. A few are left-handed. So if you are left-handed, remember that in the positive, you are shifting towards the right. Okay, so here again, I have 2.1, 2 steps, so 1, 2. The empty space I write 2. So 2.1 times 10 to the power 2 is 210. Let's see the other examples we have. Now, I have 3.5 times 10 to the power 3. So here is positive. Today we are looking at just the positives, okay? So 3.5 times 10 to the power 3. So I write 3.5 out, and then I'm going to shift the decimal between 3 and 5. 3 places towards my right hand. Okay, so 1, 2, 3. Okay, and then the empty spaces I add 0, so I have 3005. So 3.5 times 10 to the power 3 will be 3,500. Okay, now 4.721 times 10 to the power 0. Okay, now 10 to the power 0 now is 1. So it means there is no movement. So 4 point, and then 4 point is 4.721 times 10 to the power 0 will be the same, because 0 means no movement. The decimal place is at the same place. Again, 4.2 times 10 to the power 0, no movement. So the answer will be 4.2. Okay. And I said also no, 10 to the power 0 equals 1. It's not just 10. 2 to the power 0 is 1. So if you simplify something and you have to the power 0, the whole thing becomes 1. That 2 to the power 0 or 10 to the power 0 is 1. So whatever you are multiplying by, you multiply by 1. So it's the same thing. Okay. Now 6.25 times 10 to the power 0. Okay. So this will be our third example on being 0. Again, no movement. So it's the same as 6.25. 7.821 times 10 to the power 7. Okay, so it will be 7 movement towards your right hand. So you have 7.821, and then you move 1, 2, 3, 4, 5, 6, 7. The empty spaces you put zeros. Okay, so now you have 7,078,210,000. Okay, so 7.821 times 10 to the power 7 will give you 78,201,000. Okay, so I just thought it's the introduction. You need to know how to present your standard form. So if they gave you a question and they said leave your answer in a standard index form, you know how to leave it. Okay, you are not just going to roll over and let them take your marks. You are going to write it as you should for them. Okay, and then you leave your answer instant. This is the same as that, okay, but that is in the standard form. That is the actual number. So if I've been asked, we'll do a video on that as well. But today I just wanted to show you how standard form looks like, and then we'll do the positive. Hopefully tomorrow we'll look at the negatives, okay, and then we'll have numbers and try to change them into standard form, and then do some examples, and then maybe if there are other topics I want to look at before doing more possible exam questions with you, we'll start another set of that. Okay, thank you very much for to my subscribers. Okay, if you haven't considered it already, please subscribe. Do your own account and use it to subscribe. Get your notification. Okay, please follow my notes scripts. Okay, today is a lot of numbers, but we have finally gone through anyway. And beware of scammers. Okay, thank you very much for watching today's video with me, and I'll see you in the next.